Okay, we will look at problem number 5 of tutorial 2. Okay. In this problem, if you look at this, this is actually the truss. Usually this kind of truss is subjected to a, is like a tower subjected to a wind load. Okay, that is why you have this horizontal set of loads coming in, they are equally distributed, that is why 2.5 kilonewton per node is how it gets distributed. Now, as you can see, these are the bracing members, or in other words the members that they do not allow sway. Okay. The question that is asked is, I do not want to calculate everything, I just want to calculate what would be the member force in Fg and Fj, I do not need anything else. Okay. So, I just need to find out the member force Fg and Fj. Okay. If I use method of joints, I will have to start from any one of these joints and go on to perhaps joint F and joint G in order to be able to calculate this. Okay. It's difficult for you to go straight to this particular joint because there are other unknown forces existent. Okay. How do we go about solving this kind of problem? For such a question, we use what is called method of sections. Method of sections is nothing different. While method of joints, what we basically do is we focus on a particular joint and section appropriately. Method of section allows for more number of joints in a single free body. Okay. For example, if I take something like this and remove this entire top and take that as a free body, as you can see, the force on this, on this, on this and on this will get exposed. Okay. There will be 4 forces, that will unknown forces that will get exposed. Equilibrium will give us 2 relationships, 3 relationships, because this is a rigid body, right. So, how do we go about solving this kind of a problem? Okay. In method of sections, the crux of the entire thing is about sectioning. Okay. As I have already shown, there is one way that I could have sectioned, right. I can take this because these this particular section involves exposure of these 2 forces, but in addition there are 2 other forces that are coming in. Okay. Is that okay? That is the question. The answer perhaps is okay if there are only 3 forces involved, but there are 4 forces involved, which means it is going to be difficult for me to be able to tackle this particular section and directly get Fj and Fg. Okay. So, the question that I will ask is it possible to come up with some section using which it is possible to do directly these 2. Okay. Is there any particular way that I can do? Well, let us look at trying to solve only Fg. Okay. Think of section that is not necessarily a straight line, then it becomes easier for us to explore many more of them. For example, if I had cut like this, we would have exposed this, I am sorry, we would have exposed this member, this member, this member and this member, right. Is this clear? Let me just draw that separately to tell you what I am what I mean. Okay. Maybe I will erase it from here so that it is easy. This is one section, which means I can apply the unknown force over here. The other section is over here, right. I can do one more sectioning here and one more sectioning here. This will expose a force like this and a force like this. This bottom can be now removed, right. So, there is one force here which is Bj, Bc, then you have I am sorry Gj and Fg exposed, too many of them. But one important thing to note here is if I take this particular point, this force passes through this, Bj passes through this, Gj passes through this, the only one that does not pass through is this Fg. And therefore, if I take moment about this for this free body, I will be able to solve Fg directly.